Greetings, the Astro 30 here, and I have my replacement FG085 mini DDS function generator kit. I actually received this last week sometime. There we go. Alright, so this time I'm actually going to do it correctly. Now, I'll get to something that, so there's my power adapter, which I'm not going to use, so now I've got two of these bastards. This one didn't actually come with the European to Australian power adapter. Interesting. Here's the bag of parts and the LCD. It's only just like an 8x2 I think it is, or 10x2, and an empty bag. So I've just got one little gripe about this kit. Now, I did watch a video by Dr. Cassette assembling this, and he did actually make mention of the fact that these tactile switches here have to be mounted in a certain orientation, and I knew this. I'd already seen a video stating this. I just simply forgot. So see here in step B, you install components at the front, which is the switches and the rotor encoder, etc. So it says here you power it up after you've mounted everything before you actually, finally assemble it. But at no point down here do they say anything about the orientation of the switches. They actually say it over here. Important note, for all the push buttons, the side with the two dips must face the end where power is connected. Okay, so this is after you've gone through step C, which is this, where you're assembling the front and the back together, and yet they stick over as an afterthought. Oh, by the way, make sure that you've soldered all the switches with the two notches facing towards the power socket. Yeah, okay, so whoever wrote this set of instructions or laid out this document should have thought about it a little bit better. Because at no point over here, when you're looking at, oh yeah, I've got to fit all these 20 switches and that power switch and the rotor encoder, do you think to look over here? You'd actually have to read the whole entire thing first before assembling it. And because the step about the switches is here, there should be, get rid of this important note here. That's not important about first powering up and testing to see if the thing works before putting it in the case. The most important note would be about the switches. So why the hell isn't this important note about the switches over here underneath step B? Okay, so that's my only gripe about the stupid thing, because we don't notice this until last, and by that time it's too late. You can't get the things unsoldered, as I previously showed in the other video, that it just ended up destroying the switch. Now, I'm not going to make a time-lapse assembly of this kit. You've already seen me assemble it once. There's no point doing it twice. So if you want to see that, I'll put a link in the description to the original video where you can see me assembling it. And when you get up to the part of assembling the switches, totally ignore it after that, because I'm doing it wrong. And then I'll do a pickup in this video of where we go when we get to that stage. So the first stage is I'm going to do the backside components, which is the header pins, the power socket, and the capacitors. So I'm going to do that first, and then we'll move on to the switches. And a short time later, that's the back side of the board completed. That's the header pins, the DC adapter, which is, I'm using one of these 2-pin connector things like in the last one. I found another one. I wasn't going to bother trying to solder the old one. The mini USB socket up here, and the 5 electrolytic capacitors. So take your time, don't rush, because the minute you rush you make a mistake like I did. In my case, I've got the excuse that I was too busy worrying about what the camera was doing more than what I was doing. So that's how I ended up wiring, well, a good 8 of these push button switches backwards, including the power switch. So that's the next step, is to move on to the back side. I would suggest putting in the header connector for the LCD, but as I would say, leave the LCD to last, if I can find the connector. So putting in this little header connector, And then moving on to the switch and starting with the power switch, remembering that the power is on this side of the board. These switches have 2 notches, so it must face with these 2 dots facing that power connector. So it would go in like that. Okay, all the switches would go in like that all the way along. So you'd have 2 dots, 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 etc. all the way along. So every side of this switch, these switches, the 2 dots are facing that power connector. That is extremely important or it will not work. Okay, so I've got all the switches with one corner tacked in. So one, I can check the alignment of the switch to make sure it's perfectly straight before soldering all the pins. 2, so I can then just mass solder all the pins all in one go rather than having to sit there, fiddle around and flip the board back and forth. And 3, to double check that the alignment of the switch compared to where they should be pointing towards the power socket up here is correct with the 2 little dips. So if you notice, I've got all the switches with those 2 little notches. I don't know how well you can see down the bank there, but they are all facing the correct way. So now that I know that every switch is the correct way around, I can then flip this over and solder it. But just to make sure for my own sanity, I'm going to go through, triple check and quadruple check that those switches are all the right way around first. Because I do not want to have to spend another $50. I actually got this replacement for about $47, so I got it for about $3.50 off the original price. But that's beside the point. I don't particularly want to have to buy another one. I want this one to work. So I'm just going to double check, triple check and quadruple check that those switches are correct before committing to soldering them, because unsoldering them, nah, not going to happen. Power, 2 notches. 2 notches, 2 notches, facing power, 2 notches, facing power, 2 notches, 2 notches, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, and 2. So they're all facing the correct way. So now I get to solder all these little pins, and well, the one with the nearest to the capacitor here is the hardest because those pins are awfully close. So I might leave him to last. So I know all the pins are straight, I mean all the switches are straight, so I can just go ahead and solder the rest of them in. And of course where I've tacked the other end of the switch, I'll just make sure that's soldered in properly, because I was doing it at an angle like this, trying to solder it, and it may not have taken correctly. So it wouldn't hurt to check that. I actually find reading glasses a lot better doing this stuff than the magnifying glass that comes on this little stand thingy that holds the board for me, helping hand, whatever it's called. I just find wearing reading glasses a lot easier when soldering fine work like this than using the magnifying glass, because well, I don't have to keep looking around in the magnifying glass to see what it is I'm looking at to get it in focus. I'm probably not getting quite the same amount of magnification wearing reading glasses as I am with the magnifying glass. I think the reading glasses are times 10, this is like times 50 or something. Yeah. I'm just slowly going through soldering these sodding switches. Sometimes they may bridge, so I've got the solder sucker at hand ready to suck the bridge out. And yeah, see, like I just bridged it then. Then starting to get very hot here too. Actually, it's supposed to get to 36. It's about 23 in here now, and I've got a fan going, but it doesn't seem to be helping matters much. It's going to be a real hot one. So this is the last switch, and there we go. All the switches are now soldered. I hate it when it does that. The bigger the board is with this thing, the harder it is to operate. Now, all looks good from my angle. Probably you can't see, but they are indeed all soldered all the way, the correct way around for all the 21 switches. Push button switch works for the on-off, and all the momentary ones appear to spring. I'm not going to put the buttons on just yet. Next I might move on to putting the rotary encoder in. I will worry about the output socket once I get it in the case. It's not really needed for right now. So as I said in the previous video, this rotary encoder only goes in one way around. You can't make a mistake. Now, as a kit for beginners, I would probably, well, you could do it, yes, but there is a little bit of a gotcha there with these switches if you're not careful. So it pays to read the instructions, but whoever wrote the instructions in the first place, I reckon you really need to reformat that document just a little bit so it's a little bit more easier to follow, especially on the importance of the alignment of those switches, because that's a nice trap to fall into. You're going along doing it and then you realise, oh shit, they're supposed to go around a specific way. Oh, too late now, I've already soldered them in, half of them in the wrong way around. Oh, I can't get them out without breaking them. Shit, I just destroyed the kit. Yeah, you know, so as I said in the start of this video, that's my only gripe with this kit, is the instructions are poorly laid out. It would have been nice if they had made a little bit more effort in ensuring that all the important information was where you were actually up to in the assembly stage. Right, so that's the rotary encoder installed. Okay, next I'll move on to the LCD, and then we will actually get to power up and see what it does this time, before I go any further. Okay, got it hooked up to the unit's power supply. The power supply is on. Let's see what happens. Let's stand by for blowing up laughing. And we actually do have a display. It's not doing what it did before. It says restoring to default. So, ooh, it's actually changing the frequency. So that's actually doing something. Not sure what that star means yet, but okay, so let's change the mode. Select mode, CW, servo run, servo pause, sweep, okay. Continuous wave, I'm assuming is what CW means. FT, F sign. Also, where's enter on this thing? Is there an enter function? Okay, well, I can take it down in the voltage peak to peak output. It's very slow to respond though. Alright, so let's see what happens when we turn it off and then turn it back on. Because I'm thinking the way that this switch works is it was reversed in the last one and it was on to be off and off to be on, so I'm thinking it still keeps power to the CPU microprocessor in here so that it can remember what the last settings were. Yeah, see, it's gone back to where I had it set at 988 Hz at 1.3 volt output. Question is that volatile memory? So if I disconnect the power connector and then reconnect the power connector, if I can, and then turn it on, I want to see, does it still remember or does it go back to default? No, it still remembers, so it's actually non-volatile memory. That's interesting. There might be some form of super cap on there or something that's surface mount that I don't know about that stores that information, or just maybe just a ROM chip that's non-volatile. Okay, so I'm happy. I've done a preliminary test. It appears to function. The buttons do things as they should. Next step I want to do before I fiddle and fart around connect this output, there is an extra step in the instructions that they talk about, which I'll get to shortly. I'm going to use the new connector and take this old one off, because yeah, it's kind of a little bit of a hash job there. I'm going to actually connect a couple of fly leads to the output here and hook it up to an amplifier so we can see whether or not we have an output. Okay, I've just got the little BTL amplifier hooked up to a 9-volt battery over here and a small speaker because there's not enough room on the desk for this, the power supply and that and the camera. So turn this on and we see, ooh, yeah, well that's working. It's saying it's 988, it's pretty close. So I can hear it's changing in frequency. So we set that back to 1 kilohertz. There we go. Change the output voltage. To about 200 millivolts. Turn the volume on the BTL up. That rotary encoder is a bit dicey, but that does sound fairly clean, so I'm quite happy that the output is working. So now I can actually just turn that off to stop being annoying. I can actually now hook up this to the front panel and put all the switches on and mount this output socket correctly. And whilst I'm at it, stop it scratching the crap out of the desk, I'm going to stick on some rubber feet. Should I put them there? Will that look a bit weird? They might look a bit weird. I might just put them next to it. It doesn't really matter, you're not going to see it, right? And that will stop, well, this from happening. But now, it'll sit on the desk without scratching it. Okay, moving on to the front panel. Now this front panel is fairly interesting. It looks nice and shiny and glossy, but in actual fact, I've done a little bit of research here, and if you look at the very edge of that panel, you can see that it is clear. It is perfectly clear. What they've gone and done is they've taken a piece of clear perspex and they've just printed here a white outline for where the window for the LCD is. They've silk screened all the controls on the back, the labelling on the back of this piece of acrylic, and then they've sprayed it black. You can just see the word power backwards there and all the other functions. So yeah, they've printed it backwards on this side and then spray painted over the top of it black, or painted over the top of it black, so that when you turn it over and look at it, it looks all nice and glossy. Well, yeah, that's actually quite interesting. You can actually, if you look at it closely enough, you can actually see that it's inset into the plastic rather than on the front. And it would have been nice if they'd lined all them up, but they didn't. Yeah, so you don't have to worry about scratching this surface so much and destroying the lettering. This side you do. Scratch this and it'll show up like dog's balls on this side. So now I need to well, I need to mount this board, but the way I had this was, I don't think it was giving me quite enough space, and it was shorting out when I actually put the board in. Now I was thinking that maybe that was pulling on it at an angle and shorting something, because it wasn't working when it was screwed down to this faceplate, so I was thinking maybe I had to add some spacing, like with a nut or something, because the original spaces were 15mm. But what I'll try is I'll try screwing it down and then I'll put it back in the case and see if it still works. Just want to see if this works fine as it is. Apparently it does. It's not causing any shorts or anything. It's the display's still lighting up because it didn't work the first time I tried it. There must have been something with that board or the way I decided to wire the socket was shorting something out. Something was shorting. Anyway, this one's working fine, so the way I had it in the previous video of doing it this way, perfectly fine. There's just enough spacing here with this panel, and using 10mm spaces instead of 15 to give you enough room there to push all the switches. Not that I've got them in there yet. But the next step is to wire on this BNC. Okay, so the next step is we've got the BNC connector, and what they want you to do is they want you to take this this star anti-shake proof connector, which is actually the earth lead, this washer, and they want you to cut this tag off. So that's what I'm going to do now. I'm going to use a decent pair of side cutters for that. Now one bit's going to go flying or another. Okay, that was relatively painless. So you cut that bit off because it's not long enough when you bend it over to reach the circuit board, funnily enough. And then what they want you to do is they want you to solder a wire. You can use one of the offcuts of the capacitors that you did before, just to the edge there where you cut it off, just so it extends far enough to the board. So what I'm going to do is I'm going to use this link wire, as I normally do the same thing. And then it's just a matter of connecting the BNC socket up to the front panel and then soldering it to the board. First I'm going to tin the edge of that, and to make things easier I'll tin the end of the wire. As easy as that. So then I'll just cut it off. I'll give myself a good inch and a bit. That should be more than enough length of wire there. Just get it as straight as possible for it to actually go through the board and make contact with the earth. Now I'm going to put it in the front panel. Okay, so we grab our front panel. I'm going to pass the BNC socket up through the front with one of the washers on the front. I believe that's how they want you to do it. I can't see any other way you would do it. And then you put this over to the far edge pointing outside the case because the ground connection is on that side. So I'm going to put this nut on like so, and make sure everything's still straight. I'm going to do up said nut. Okay, so now I've got that as tight as I can. I can now introduce the board to my connector. Get the ground to pass up through its hole. Now I'm just wondering if that's even going to make contact with the BNC socket. Actually, I probably should take this protective film off the LCD because I won't be able to later. Looks like it is just touching it. I don't know if you guys can see that, but it does look like it's just touching it. Tin it first. Now I heat that. I don't know if that actually soldered or not. I believe it is making contact. So I'll just apply a little bit more heat. Yeah, I do believe that it is soldered. So I'm pretty sure that that is soldered. It looks like it anyway. I can could see solder touching the gold plating of the or whatever that is, of the BNC sockets connector. So I can just solder that ground lead in, trim the excess like so, and just make sure that these screws are tight. Just pop them through the front like that and just push on them and they will seat. So I'm glad that this second one worked out, so I don't have to then spend another 50 odd bucks and buy another one. It's nothing worse than destroying something that you spent a couple of hours working on just simply by making one basic error. Okay, now that it's all hooked up and got the buttons on, I'll just do a preliminary power on test, make sure it still powers on, which it does. And let's see what it goes back to. Yes, it goes back to where it was before, which was 1000 Hertz at 0.2 of a volt. So it's been unplugged for a good 20 minutes and it still remembers where it was. That's a very nice feature. So I can just check that, yeah, frequency is increasing. I can just now put my rotary encoder button on, and that's the kit complete. So I'm just going to hook up the amplifier again and see what the output's like. Okay, got the amplifier hooked up. Makes a bit of digital noise when it's booting up. There we go, but the well, it's working, it just sounds a bit distorted. I wouldn't say it's very clean either, it sounds like there's a bit of digital noise there. So, time to hook up the DSO and have a look at what we've got as an output. So I got the DSO hooked to the output, and as you can see it's very hairy or jagged. Just going to increase the voltage per division. I mean the voltage output, I can't see the display. There we go, at 400 millivolt. Yeah, it's roughly 200 millivolt positive, 200 millivolt negative. Let's get rid of all that information we don't need at the moment. It's not very stable, is it? It's very jagged. You can see there's a lot of digital noise if this would trigger correctly. You can see when I hold that, you can see that it's very, very messy, rough. Can't think of a word to describe that. It's just got a lot of noise on that. Most of that is digital switching noise. So yeah, the output is not exactly all that clean, as you could hear through the amplifier. Well, I hope you could hear through the amplifier. I did, but I don't know if you did. Point is, I could hear that it wasn't very clean, and I can see that it's not very clean. For what it is, yeah, it's okay, but it's not the be-all or end-all of function generators. But it'll probably do for the price that it cost. So, okay, so say I wanted to change the frequency, I'd press the FT button, the display changes to F colon and a line, and I can just enter on the keypad 1000, for example, and then you have to select what unit you're using, these two keys here, either as Hertz or as kilohertz. I want 1000 Hertz, which is 1 kilohertz. Do that, and now we're at 1000 Hertz. You can do the same thing with the amplitude. Press the amp button and it changes to a line, and if I say want 1 volt per division or 1 volt output peak to peak, I can just go 1. Yeah, so because these two unit keys either does hertz, volts, seconds or microseconds, the second one does kilohertz, millivolts and milliseconds. So if I wanted 1 volt, I would press this first key here, and now we have a 1 volt output. Very neat. So I guess if we wanted to change the waveform, we press the WF and we've now on square, and I'll bring that into shot now. You can see that, yeah, it is a square wave, although it's still very noisy. Press the WF for triangle. Indeed, we have a triangle wave. Press WF again. RMP plus, so that's like a sawtooth. Okay. RMP negative, so that's a reverse sawtooth. Yeah, okay. And STR plus, so that'd be a staircase like waveform. On the plus side, so the stairs are going that way, and I guess if you do it again you get one that's minus, which is going the other way, as you can see. User defined. Okay, so I got interrupted there. Some issue with the toilet. We're on user and back to sine. Although, yeah, that's a sine wave. It just looked like triangle to me. It's just on a very high voltage per division. So, yeah, it's working. The output's not very clean. This heatsink on this regulator, ooh, that is actually getting quite hot, believe it or not. So it was probably a good idea having a heatsink on there. Right, so the DDS is complete. It now works properly as intended. So yeah, I might put the lid on and call this done. I might add some cable ties to these wires first, and then yeah, call it done. So there we go. The top cover is now on, screwed in, and it still doesn't have a power switch on the front, but you wouldn't leave it plugged in all the time anyway. And it's still working. Anyway, I'm the Astro 30. If you enjoyed this video, please remember to rate, comment and subscribe below. And you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyway, this is the Astro 30 saying see ya. Happy sine waves.